In this final example, we're going to look at a problem that goes backwards. We're given a picture. We have this triangle OX prime Y prime and the smaller triangle OXY. And what we've been told is that XY is parallel to X prime Y prime below. We know these two sides are parallel. The question is, can we use that information to determine if the two triangles are similar? The triangles here being the gray smaller triangle OXY and the larger triangle OX prime Y prime. Do you think we have enough information? Don't look ahead in part B. Tell me why if you think they are similar. Okay. When I look at this problem, the reason I think that they are similar is because, again, I'm using what I know about parallel lines. Both triangles already share one common angle. Both triangles have this angle O is in both triangles. We can think of it both as being the angle XOY, but it's also the same angle in terms of measure and actually being the same angle as the angle X prime OY prime. And for that reason, I already have the angle part of side, angle, side. Now what I'm going to need to do is either find another angle, right? Two angles is enough for similarity, or I would want to check proportionality of sides. Here's something I noticed. I don't really have side, angle, side information here. The reason I say that is because I do not currently know the lengths of the other sides of the large triangle that are forming that angle. So I don't have enough information to know if there's proportionality along the angles that the sides that make my angle O. But I do know something else. I have those parallel lines. That means I can find corresponding angles. What pair of corresponding angles do you see formed off of my parallel lines XY and XY, X prime, Y prime? There are two pairs. One pair of angles you might have chosen are the pairs formed at Y and at Y prime. The ray OY prime forms a transversal between my two parallel lines, and Y prime are corresponding angles. These are corresponding angles, so they have the same measure. Now that's enough. I've now got two angles of my triangle because angle O is in both. So at this point, I have angle-angle similarity. But if you had decided to pick the other pair of angles, you're also correct, because the transversal OX prime crosses my two parallel lines, forming corresponding angles at OXY and OX prime Y prime. So I actually get angle, angle, angle here really, really fast. These triangles are congruent, are similar by angle-angle criterion. I'm going to pause here while I write the rest of this part. Now that I've established the two triangles are similar, we can look at part B. The question is, can we find the length of side OX prime? So remember, I said that the larger triangle, we didn't know the lengths of those sides. Do I have enough information to figure it out? If you guess yes, we do. You are right, because in this picture, I do have one set of corresponding sides that are given. It's my two parallel lines. I just need two corresponding lengths because once I have two, I can figure out the scale factor and write a proportion I can use to find the length that I don't know. So here's what we're going to do. We know that the length of OX prime should correspond to the length, the smaller length on that same ray, the ray that I'm now highlighting in orange, that goes through O, X, and X prime. So that means that the other length it should correspond to is OX. And you'll notice we know the length of OX. But because I have similar triangles, that ratio should be the same as the length of any side, other side in the large triangle over its corresponding length in the small triangle. And my two parallel sides did both have lengths given in the problem. I noticed that I know the length of X prime, Y prime. See, it's right here. It's 6.25. And I also know the length of the smaller triangle side that corresponds to that one, the parallel segment XY. So I know that because they are similar. This is a ratio I can set up. I actually can add in the third side set, OY prime over OY. Have all three of these ratios. Now let's put in the information we know, and we're going to focus first on this part and write a little proportion we can solve to find the length of the side we are seeking, in this case, OX prime. So I'm going to name the length of my side OX prime. I'm going to name that length Y. Now, Y is bad. We already have a Y. Let's call it N. So its length we're going to call N. So I'm going to have the length of OX prime, which I'm going to call N, divided by the length of OX. That's 4. Then I'm going to set that equal to the length of the X prime, Y prime. That's that bottom length in the triangle, 6.25, divided by the length of XY, which is 5. So I have this proportion. Now, I could divide on the right and get my scale factor and then multiply by 4. That's fine. Alternatively, I can use my cross products again. And I'm going to do that right now. So I'm going to convert this to a statement in terms of cross products. And I'm going to say that N times 5, right? I multiply across must be equal to 6.25 times 4. I'm going to do the math for that right-hand side out loud. 6.25 times 4. So I'm going to take 6 times 4, which would be 24. And I'm going to add to that 6 times 0.25. Well, I know 0.25, that's 1/4. 4 times 1/4 is 1. So I'm adding 24 and 1. And I get 25 on the right. And on the left, I have N times 5. So now to find out what N is by itself, I just divide. Dividing both sides by 5, I find out that N is 5. So it turns out that side OX has a length, OX prime has a length of 5. So my answer is OX prime's length is 5. That wasn't the same as the length in the smaller triangle for any particular reason. It just ended up being that when I multiplied by that same ratio, I got the same number as the length of one of the sides in the smaller triangle. Notice they didn't correspond, so that's why. I now can do the same thing with the other one. So I'm going to set up that proportion for you. And the very first thing I want you to do once we stop the video is to solve it. In fact, start solving it as soon as I write it down. Here we go. We're going to take our 6.25 over 4. That's that center portion of my proportion right here. And I'm looking for OY prime now. So I am looking for the length of OY prime divided by the length of OY, which is 6. Make up whatever variable you want to hold the place of length of OY prime and solve that proportion.